So the next lesson is going to cover the relationship between Java streams and other things in Java that you may be familiar with or will be familiar with if you play around with Java long enough. And in particular, we're going to contrast Java streams with Java I/O streams, which sadly have a bit of the name in common, but they're not at all the same, and Java collections, which also don't have the same name, but they may have some of the same sort of behaviors at some high level. So we're going to talk about comparing streams with I/O streams and collections. So Java I/O streams are different from Java streams, despite the fact they both have the word stream in them. So on the left-hand side over here, we're showing what an I/O stream is. And on the right-hand side, we're showing the abstraction of what a Java stream is. And they are not the same, indicated by the not equal sign. So we'll see that an I/O stream is typically used to get data off of often persistent storage, like a file, and then convert it into something sadly called a stream. But it's a byte stream, not a Java stream. And then get it into the program where you do computations on it. In fact, you can use it with a Java stream very nicely. And then later, when you're done with all your processing and transformation and filtering and so on, you can then take your data and store it on a data source using a Java I/O stream. And again, the key thing to remember is that stream and I/O stream is really dealing with a stream of bytes, not a stream of data elements. But I realize that's a little confusing at first glance. As I mentioned, they're often used together. So you can have an I/O stream and a Java stream. And in fact, we do lots of that. And the programs that we work on here do that all the time. And your program does that. I abstract away from a lot of the I/O stream level stuff by the skeletons that we give you. But if you peek around and are curious, you can see how all this stuff works under the hood. Java collections are also different from Java streams. And in particular, here's an example of a Java collection on the left. This is an array list. So an array list, as you probably know, probably from taking CS 1101 or something equivalent somewhere, it's a data structure that has a contiguous chunk of memory that stores pointers to elements. So if we have an array list that has size 5, we've got 5 elements at the 0th, 1st, 2nd, 3rd, and 4th location. And just for kicks, let's assume we're storing points. Why not? And so we're going to have x and y coordinates, which in this case are doubles. And so that's kind of what an example of a Java collection might look like. And there are a boatload of other collections, right? There's maps, there's hash maps, there's tree maps, there's concurrent hash maps, there's tree sets, there's linked lists, there's all kinds of stuff. And they're all typically represented with some type of data structure that you probably have learned about in CS 2201 or, again, something equivalent. And that's quite different from a Java stream. So let's talk a bit more about this. This will hopefully answer some of your questions from before. A collection is typically an in-memory data structure that can be used to store, retrieve, and manipulate groups of elements or a collection of elements. Trying to come up with another synonym for collection. It isn't collection, so groups of elements. So again, here you can see we have our good old array list, which is an in-memory data structure, and you can use it to manipulate elements. And the manipulations you can typically do are things like, add an item to the collection, remove the first item from the collection, remove the nth item from the collection, check to see if the item is in the collection at some location or whatever. You can kind of think at a high level of a collection as being sort of like a DVD. It's not quite perfect analogy, but the idea is you've got a fixed amount of content stored somewhere. In this case, it's on a CD or a DVD, but think of it as a fixed collection of stuff. You're not really adding much to that. So all the content in a collection or in a DVD exists statically. In contrast, a stream is a fixed data structure that processes elements on demand. So you get data from somewhere, which, by the way, could be a collection. It doesn't have to be. It could be an I/O stream. It could be from other sources. But you get data, and then you do a bunch of things to it. You manipulate it by applying these aggregate operations, things like filter, like map, like flat map, like sorted, and so on and so forth. So you can do a bunch of different things to the elements in a stream without explicitly having to iterate over them. Now, there is iteration, of course, taking place, but it's done internally using the streams framework, and that's all handled for you magically under the hood, behind the scenes. So you're processing the data as it flows through these aggregate operations. So you can think of a Java stream as somewhat like a flow of bytes in a streaming video, although, again, that's not quite the right abstraction because it's not really a flow of bytes. It's a flow of data or a flow of elements or a flow of values or a flow of objects or something like that. There's structure, in other words, to what goes through a Java stream. But the idea is it's flowing through and it's being transformed somehow in the pipeline. Maybe a better analogy might be, the water flowing through the water filtration system or something like that. And so the content is dynamically received and processed in the context of the operations that exist in the stream. Now, just to help connect all the different pieces, there are various factory methods that you can use to convert collections to streams and vice versa. So we can use things like stream and parallel stream to take collections like array lists or hash maps or tree sets and whatnot and convert them into streams, and then we can apply a bunch of processing. And, no surprise, there's also factory operations called terminal operations that can be used to take the results in a stream and convert them back into various types of collections, lists, sets, maps, and so on. So you can go back and forth. So the concept of a collection and a stream is often very tightly integrated. I won't say tightly coupled, but tightly integrated conceptually, but they are separate and distinct things. Here's a nice example, hopefully, that illustrates how you would manipulate elements in a Java collection, and then we'll compare and contrast that briefly with a Java stream. So in this particular case, we've got a bunch of links. This is to my old website at Washington University, which I think might even still have some of this stuff there. And we're going to program this using the old-fashioned Java collections approach. So you can see that we're going to also illustrate something called external iteration here. I'll talk about that in a second. So we take this array and we convert it into a list of strings by using the arrays.asList factory method. And then we're going to write kind of old school Java for loop. This is what's called an index-based for loop that's going to iterate through every one of the elements in that list of strings. And if the list contains the Washington University substring, then we're going to replace it. If it doesn't, we're going to skip and keep going over here. So this is what's called external or explicit iteration. We iterate through it explicitly. And you may have written code like this. I've certainly written code like this. It's kind of ugly, and it's a little hard to tell at first glance. It has all the control construct stuff littered in the code, and you have to kind of sit there and work through your head to see what it's doing. One of the nice things, however, with external iteration is you get to have fine-grained control of loop behavior. So here we do a check and we continue, or we could exit, or whatever. Let's compare and contrast this old-school way of doing things with the newer way of doing things. This is a stream-based solution that does exactly the same thing. We start out with the same data, except now we're going to apply a bunch of operations from the streams framework, a creation operation of a couple of intermediate operations, filter and map, and then the collect terminal operation. And this will show the concept of fluent interface. We're going to chain the transformations together. We're going to have internal iteration. No control flow is overt here. It's implicit and so on. So what we do here is we implicitly iterate through a pipeline of elements from a collection. So we take this collection, using the word loosely, this array, convert it into a stream with the of factory method. We then filter or transform each of the values. If this contains, only let things through that have this substring, otherwise ignore them. And once we've gotten through that, replace this substring with this substring. So that's what map is doing. And then create a collection as a result. And there's some other nice benefits here as well, which we don't see here. You just have to do a lot more work here. This is prone to accidental complexity if you get the loop counter off by 1, which is sadly not too uncommon problem when you program index-based for loops. You'll have problems. This approach, in contrast, makes it much more difficult to get it wrong. So we get a result here as a collection. Notice, by the way, that this was the factory method that made ourselves a stream, and then this is the terminal operation, which is the reverse factory method that converted the stream back into a list. Like iterators, elements in a stream can only be visited once in a lifetime of the stream. Streams also simplify together chaining of transformations. You can notice here that we can go from having a list of strings to a list of URLs by just adding in another map operation that converts the string into a URL. So that makes it a little bit easier. And we won't talk about this in detail now. We'll cover it later. There's a cool little exception laundering adapter called rethrow function, which you can read about at this link, and I usually use it in my programs to avoid having to deal with silly checked exceptions, which are ugly. OK, so that's the end of the overview comparing streams with IO streams and collections.